So let's do one of those right now. What if you were integrating from negative infinity to 1 of the integral 1 over 2x minus 3 squared dx? Okay? And then we said u is going to be equal to this in the bottom, 2x minus 3, so that du is equal to 2 times dx. du dx is 2, and then we move the dx over. Okay? So then dx is equal to 1/2 du. So when you do this integration, you'll have negative infinity to 1, and don't forget this is x. These limits are in terms of x. Okay? And you'll have 1 over u squared, because we defined u like this, but then dx we defined like this, so we'll have 1/2 du. Okay? So, in the end, you'll have 1/2 integral of u to the minus 2 du, but in order to do this, we have to change our limits of integration. If you plug in negative infinity into here, you'll get u is equal to, again, negative infinity. 2 times negative infinity minus 3 is just going to give you, again, negative infinity. And if you plug in a positive 1 in here, 2 times 1 is 2 minus 3 is u is equal to negative 1. So that's the upper limit. This should all be familiar from our other section on definite integrals. So you have 1/2, and to pull this integration off, it's going to be 1 over exponent plus 1 is negative 1. Negative 2 plus 1 is positive 1 times u to the negative 1, just like this, evaluated from minus infinity to minus 1. And so to simplify this, you'll have negative 1/2 times 1 over u evaluated, negative infinity to negative 1. And so then, in the end, you'll have negative 1/2, okay? We'll do it like this, negative 1/2, and you plug in the top limit times 1 over negative 1. We just plug this in here, minus evaluated at the bottom, which is negative 1/2 times 1 over negative infinity, like this. And so this is going to be negative times negative gives me positive 1/2, okay? And I'll have a subtraction here, okay? But inside here, I'm going to have negative times negative gives me a positive, but everything's divided by infinity, you see here, so this is going to be 0. Because you have basically 1/2 times, and then this over here, this becomes 0. Anything divided by infinity gives you a 0, okay? So then negative times negative gives you positive, and then anything divided by infinity gives you 0, so you have this. So in the end, because that goes to 0, in the end you have 1/2. So then this integral does converge, and it converges to the answer 1/2. So I'm not going to work any more of these problems because they're not that terribly different than what we've done before. But basically, you have an integral, and it's called an improper integral when one of the limits is infinity. And so then you just do the integral the same way we've done before, including transforming the integral limits themselves if you need to, if you do substitution. But in the end, when you plug it in, you plug in infinity as if it were another number. And I just showed you a case when it blows up and it doesn't give you an answer that converges. And in this case, I've shown you when in some cases the infinity can force you to 0, and so you can actually end up with a solid number. This would be an example of some kind of integral where it went down so close to 0 so rapidly that the actual area, even though you're integrating from minus infinity, I'm kind of drawing my graph a little bit wrong here, from minus infinity all the way up to a number, so you've got minus infinity on forever and ever and ever, and you're adding up stuff, it actually converges to a solid 1/2.